Most vehicles are remembered for how powerful they were. This one was remembered for how little power it needed. On paper, it didn't make sense. 3 wheels, a fabric roof, an engine smaller than most motorcycles. But somewhere between post-war scarcity and open Autobahn asphalt, something extraordinary happened. Because sometimes, performance isn't about horsepower. It's about efficiency taken to its absolute limit. This was the story of the Messerschmitt KR200. In the late 1950s, highways were becoming symbols of power. American V8s thundered with 300 horsepower. Grand Tours chased speed with 6 cylinders and chrome. And then, slicing quietly through the air, came something else. A narrow teardrop with a bubble canopy, looking more like a cockpit than a car. Inside, 2 people sat in tandem, one behind the other, like a fighter plane crew. And somehow, this tiny machine could cruise at 70 miles per hour, with just 10 brake horsepower. The KR200 wasn't born from a car company. It came from Messerschmitt, the same company that had built some of Germany's most advanced fighter aircraft during World War II. After the war, they were banned from producing airplanes. Factories stood silent. Engineers trained in aerodynamics and lightweight construction had nothing to build. So they asked a different question. If you can't build something that flies, what's the most efficient thing you can build that drives? Germany in the early 1950s was rebuilding. Fuel was expensive. Cars were expensive. Motorcycles were common but exposed and uncomfortable. The government created a special vehicle classification: 3 wheels under 250 cubic centimeters, taxed like motorcycles, licensed like scooters. It was a loophole, and engineers love loopholes. Fritz Fend, an aeronautical designer, had already been experimenting with small enclosed scooters for injured veterans. Messerschmitt had factories and aerospace precision. Together, they created something that ignored automotive convention completely. The KR200 weighed just over 500 pounds, less than a modern engine block. Its body wasn't stamped steel. It was a tubular space frame, covered in lightweight panels. The shape wasn't boxy, it was a perfect teardrop, refined in wind tunnels originally meant for fighter planes. Its drag coefficient was around 0.35. For context, many large American cars of the same era had drag coefficients near 0.55 or worse. The KR200 wasn't powerful, it was slippery. And that made all the difference. The engine was a 191 cubic centimeters single-cylinder 2-stroke, mounted behind the passenger, driving the rear wheels directly through a 4-speed sequential gearbox. No differential, no complex drivetrain, minimal power loss. It produced around 10 brake horsepower. That number sounds impossible. But with so little mass to move and so little air resistance to fight, it was enough. Acceleration to 30 miles per hour was surprisingly brisk. Highway cruising was steady, and fuel economy ranged between 70 and 90 miles per gallon. Not with hybrid systems, not with computers, just physics. Then there was the reverse gear, or rather, the lack of one. Instead of installing a conventional reverse mechanism, engineers did something only aircraft-minded designers would attempt. To reverse, you stopped the engine, turned the ignition key the opposite direction, and restarted it. The 2-stroke engine simply ran backwards. All 4 gears worked in reverse. It was absurd, it was brilliant, and it perfectly captured the KR200's philosophy. Solve the problem, but do it lighter. The suspension borrowed concepts from aircraft landing gear: leading arm front suspension with rubber elements, swing axle rear. Simple, light, effective. Steering came through handlebars, directly connected to the front wheel. No power assistance, no delay. You turned. The car responded instantly. The turning radius was tighter than most taxis. In city environments, it felt almost surgical. The cockpit felt like entering a machine, not a car. The bubble canopy opened to the side. You stepped into a narrow aircraft-style seating position. Forward visibility was panoramic. You sat inches from the ground. Every speed felt amplified. Every movement felt mechanical and direct. There was no insulation from physics. That was the point. Traditional automakers laughed. 3 wheels, 10 horsepower, a sewing machine engine. But production numbers told a different story. By the late 1950s, tens of thousands had been built. Students bought them. Young professionals commuted in them. Even celebrities quietly drove them. So not because they were luxurious, because they were logical. The KR200 wasn't fast in absolute terms. But compare context. A typical American car weighed nearly 4,000 pounds and consumed fuel at 12 miles per gallon. It required 200 horsepower to reach 70 miles per hour. The KR200 achieved the same speed using a fraction of the mass and a fraction of the power. It wasn't magic. It was efficiency layered everywhere. Aerodynamics, weight reduction, direct drive simplicity, minimal frontal area. Every component justified its existence. Manufacturing reflected that philosophy. Aircraft-trained workers assembled each unit with precision. The entire vehicle required significantly fewer man-hours than traditional cars. Material usage was minimal. Waste was minimal. Even maintenance was simple. The engine could be removed quickly. 2-stroke design eliminated oil changes. Tires lasted longer due to low weight. Owners could maintain them with basic tools. It wasn't just efficient to drive. It was efficient to own. Safety was unconventional but thoughtful. The central driving position reduced certain impact risks. The low center of gravity made rollovers rare despite 3 wheels. The biggest risk came not from instability, but from other drivers misjudging its speed. It looked slow. It wasn't. By the early 1960s, Germany's economy had recovered. Fuel was cheaper. Buyers wanted conventional cars, and Messerschmitt regained permission to build aircraft. The company returned to aerospace. KR200 production ended. But the idea didn't. Today, surviving KR200s are collector pieces. Engineers still study them, not because they were powerful, but because they were optimized. Modern electric vehicles chase similar principles: lightweight construction, low drag, direct power delivery. The KR200 explored those ideas decades earlier, without computers, without simulations, just slide rules and wind tunnels. It proved something fundamental. Performance isn't always about more. Sometimes it's about less, applied perfectly. Less weight, less drag, less complexity, more thought. In an era obsessed with horsepower figures and oversized vehicles, the KR200 feels almost rebellious. A machine that asked, how much do you really need? How much power is sufficient? How much fuel is acceptable? Its answers were radical then. They still feel radical now. Because the KR200 wasn't trying to be a car. It was trying to be the most efficient enclosed vehicle possible. And in doing so, it quietly humbled machines with 10 times its power. Not through force, but through design. And sometimes, that's the most powerful statement of all.